Hello, Math 2 students. This set of notes is on expressions and exponents, and this one shouldn't take as long as the last couple days have taken, but you have been assigned a new, let me see if I can find it. Okay, yeah, this is Math 2. You've been assigned an additional, it's called a, well, it's in the quiz section, but it's not a quiz. So you've been assigned some additional factoring extra practice, but I'm going to go through a few of those problems with you when we finish these few pages, and they're down here. And I also gave you some of the answers. So I picked out 5 of those problems out of the 10, and I also gave you the answers. So it's not meant to be a quiz grade, it's just meant to be extra practice and a classwork grade. Okay, so let's talk about expressions and variables. What is a variable? And we'll use our text box with our microphone today for this. Letters that represent unknown values. Should have done red. I'll do that next time. Give an example of a variable. A variable would be our X or our A, B, Y. Any of these could be used as variables. What is an expression? An expression is different from an equation. It doesn't have equals marks in it. So let's see if we can use our text box again. Numbers, symbols, and operations that are grouped together to represent a pattern. Okay. There we go. Write an example of an expression. Something like 2x plus 1. So there's no equals or anything. It's like a polynomial or whatever. Another example with 2 variables would be 2a plus 3b minus 1. So those are examples of expressions. Sometimes when we're given an expression, we are given a value for the unknown, and we do what we call plug in or substitute the values. So if our equation, it's not an equation, it's an expression. If our equation is 2x plus 1, then what we would do is if x is -3, we're going to plug in the -3 for the x. So we would plug in, instead of writing the x, we put the -3 in there. So 2 times -3 is -6 plus 1 is -5. If we have 0, we would plug in a 0 for the x. 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. Plug in a 5 for the x, and you don't really even have to write it down. If it's short like this, 2 times 5 is 10, plus 1 is 11. All right, same thing over here. If we have 2, and these are not my set of notes. It's not an equation, it's an expression. So if my expression was 2x plus 3y minus 1, and I'm given the x and the y, so in this case I'm going to plug in the -3 for the x and the 1 for the y, and then do the math there. That's -6 plus 3, that's -3, minus 1 is -4. Here we're going to plug in a 0 for the x and a 2 for the y. 2 times 0 plus 3 times 2 minus 1. So that's 0 plus 6 minus 1 is 5. So that's all this section's about, just plugging in your values. 2 times 5 plus 3 times -4 minus 1. That's going to be 10 plus -12. I'm going to write that down here. 10 minus 12 minus 1. That's going to be -2 minus 1. That equals -3. Okay. Let's move on down. Let's talk about exponents. So what is an exponent? Again, I'm going to use my text box to define an exponent. A number that tells you how many times a number or expression is supposed to be multiplied times itself. Okay, what does the base tell you? We're going to do another text box right here. The number that is going to be multiplied over and over again. Okay. And then what does the exponent tell you? The exponent tells you how many times you multiply the base by itself. All right, so we got our definitions. Let's look at some examples. Oops. So the exponent in this this little term right here is the 4. So that's what was defined in this part. The base in this. Oh, I'm sorry. I'm not reading the directions. Sorry. Let me undo that. Okay. It says underline the base and circle the exponent. So here's the base and here's the exponent. Underline the base and circle the exponent. Underline the base, circle the exponent, and then explain what the base and exponent are telling you. So this one is telling me to multiply 2 times 2 times 2 times 2. This one is telling me to multiply -6 times -6. And then this is the base, this is the exponent. This would be y times itself. 7 times 1, 2, 3, 4, 5, 6, 7. And this is a much easier way to write it right here. Exponential form. Okay, so let's talk about what exponential form and factored form look like. Okay, so we're going to use the example 4 squared. So that's exponential form where you've got the exponent here. Factored form for that would be 4 times 4. And then multiplied form would be when you actually multiply it out and get your 16. Exponential form of, let's say, 7 to the 3rd power. That's the exponential form. The factored form would be where it's written out times itself. And then the multiplied form, when you multiply it all together, 7 times 7 times 7 is 343. So those are the difference in those terms. Okay. So we're going to talk about several different types of exponential expressions and what they look like. Short way versus long way, or the kind of expanded version versus the short version. So using exponents to shorten an expression with multiplication in one variable. So this is the same variable multiplied times itself 4 times. We could also write this. Let me get a different color. We could also write this as a to the 4th power. Looking over here, this one's written in exponential form. If we wanted to write it out the long way, we would write b times b times b. Or we could even write the b's just beside themselves like that. That would be fine too. Oops. Okay, so use exponents to shorten an expression with 2 variables in parentheses. Okay, so because these are the whole AB is multiplied times itself 3 times, the way we would want to write that is in parentheses, write the AB in parentheses, and then on the outside of the parentheses, put the 3. There's a difference in this and this. If you see this without the parentheses around it, this means only the B is multiplied times itself 3 times. So that would not be the same as what's up here in red. Okay, over here, write out an expression with multiplication of 2 variables in parentheses the long way. So this is kind of the opposite of what we did over here with the AB. We're going to rewrite this as xy times itself 4 times. Okay, moving on down with the 3 B's. Use exponents to shorten an expression with multiplication of a variable and number in parentheses. So this 3b is multiplied times itself 3 times. Again, we have to use our parentheses here to get this right. Okay, that is not the same as this, because in this case it would only be the b that's been raised to the 3rd power. In this case, it's the 3 and the b that are raised to the 3rd power. If I wanted to write this in multiplied form, I would take 3 and multiply times itself 3 times, so that would be 27, and that would be b cubed. So this would be right, but this one would be wrong. Okay, what about this one? 5g, and that whole thing is to the 2nd power. We would write 5g times 5g, both in parentheses. Okay, so to write something like this, we've got a variable, we've got an expression with a variable and a number that are added together. We could rewrite this, x plus 2, and then the exponent of 2 on the outside. This one over here would have to be written, I don't know if I can write this small enough. like that. So that is multiplied times itself 4 times. All right, this is what we're going to see a lot, where we have the letters. These are multiplied times each other. M times N times N times N times P times P times P. We could rewrite this as M squared, N squared, P to the third. And then this one over here, going the other way around, we could write X, 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 Y, 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 Y. All right, and the last two, the 2 times the 4, we would actually multiply that 2 times 4, 8. And then that would be X squared, Y squared, and Z. And then this one, we're kind of going the other way around. We could write 12 like 3 times 4, or we could write 2 times 6 or whatever. We're not going to do that. We're just going to write 12, 4 C's, and 2 D's. Okay. So those are just some examples of what you might see with exponents. All right, next example, next set of examples is, it says, do parentheses make any difference? Well, we've got 2 different examples here. We've got this one without the parentheses and this one with the parentheses. If we write this first one the long way, we're going to write 3 times A times A times A times A, because the 3 is not raised to the 4th power. Only the A is raised to the 4th power. Now this one in the middle, though, the 3 and the A are raised to the 4th power. So we would want to write, we could do it a couple different ways. We could write it like this. We could also write 3 to the 4th power, A to the 4th power, or we could just raise 3 to the 4th power. And I can't remember what that is. It's going to be, hang on, get my calculator. $81. Okay, so it would also equal 81A to the 4th power. So it's different than this one over here on the left, because if you've got something in parentheses, then everything in the parentheses is raised to that power. And let's see, what do we want to put here? Let's use our text box again. Because of the parentheses, the second expression also takes 3 to the 4th power. I guess that'll work. That should say parentheses, but that's okay. Okay, give another example of a difference between a term and an exponent attached to parentheses and an exponent that does not have parentheses. So we'll just make up another example. So something like 4v squared or 4v in parentheses squared. So this would be 4 times v times v, and that does not equal 16 times v times v, because over here on the right side we raise 4 to the 2nd power. So we multiply the 4 times itself because it's in the parentheses. Equivalent expressions. Text box. An expression that has the same value as the equation you are working with. Okay, let me give you an example. 2 and then x plus 4 in parentheses equals, oh, let's say and then if you multiply that out, 2x plus 8, those are equivalent or equal expressions. Okay, so a term. And we talked a little bit about this already with the polynomials. A term, a number, comma, a variable, comma, a product of a number and variables, comma, or a quotient of a number and variables. Let's do some examples. A term is something like 2b or 3x squared. Just x would be a term. 8 would be a term. negative 4m would be a term. So something like 3x plus 2, that would be an expression, okay? And these are the terms, and we can combine these. Like we could do 2b minus 3x squared. This would be an expression. And each of those things is a term. So the 2b is a term, and the negative 3x squared is a term. What's a coefficient? The coefficient is the number in the term. So taking the 2b, the 2 is the coefficient of b. Okay. Just another example, let's do the 3x squared. The 3 would be the coefficient. Okay. So that was actually the end of the note. So I want to look at these 5 of the problems that are in your other classwork today, your extra practice. This comes from yesterday's assignment where we were factoring quadratics or trinomials. So all of these, you will be able to do it like with the 1 in front of the x. So remember that what we want to do is we want to look at this number right here, and we want to find a factor pair for this number. And we need that factor pair when we combine those numbers, we need them to make negative 2. Okay, so factor pairs for negative 48. The first one I think of is 8 times 6. One of them has to be positive and one has to be negative. Okay, so either negative 8 times 6 or 8 times negative 6. Okay, so which one of those, if I put a plus between them, makes negative 2? It's going to be this one. So this is what's going to go in the parentheses. So my parentheses are going to be x minus 8 and x plus 6. So which one of these matches? The x minus 8 and the x plus 6. Answer choice A. So let's look at number 2 down here. All right, so this one's a little bit tricky. I did want to show you how to work this one because we didn't do any like this. So let me rewrite this. So what I can do, because 8, 16, and 8 can all be divided by 8, I can take that 8 out. Okay, and then what I do is I just divide these each by 8. So that's going to be x squared. 16x divided by 8 is 2x. And then 8 divided by 8 is plus 1. So then what I can do is I can just take this part and factor it. Okay, so what I'm looking for is a factor pair for 1 that when I add it, I get 2. Well, there's only one factor pair for 1, and that's 1 times 1. So I know I'm going to keep my 8 there, and then I'm going to do my parentheses. And it's got to be positive 1 and positive 1. So x plus 1, x plus 1. So this also, and if you think about our exponents that we just got through talking about, x plus 1 times x plus 1 can also be written like that. So which one matches that? Looks like C. Answer choice C. Okay, so that was number 2. 3 is over here. Okay, so number 3, I can actually kind of do the same thing. I can take out a 4 here, but I don't want to because it's not going to match one of these. This is the difference of 2 squares, though. And if you remember, to factor the difference of 2 squares, you're going to have a plus and a minus, and then the first term needs to be the square root of this right here. Well, the square root of 4 is 2, and the square root of x squared is x. So 2x is the first term there. And then the square root of 16 is 4. So this is factored right here, and what they're asking me is which one of these is one of the factors. And so the only one that matches is D, because that is the same thing as that right there. All right, number 4. Okay, this is also the difference of 2 squares. You just have to recognize that, and this time it's a t. So it's going to be t plus something, t minus something. The square root of 36 is 6. So that's going to be answer choice B. And the last one. they're asking for the other factor, but I'm just gonna factor this and see what matches. Factor pair for negative 24, that when I combine it, I get 5. Let me think about the factor pairs for 24. 2 times 12, 3 times 8. How about 3 times 8? Okay, 3 times 8. Okay, that doesn't add up to, oh, I'm sorry, that's not even a factor pair for negative 24. It's got to either be a negative 3 or a negative 8. So negative 3 times 8 or 3 times negative 8. Okay, so which one, when I put a plus here, makes positive 5? It's going to be this one right here. Okay, so my factored form is x minus 3, x plus 8. Okay, so which one? C. That matches that right there. All right, so that's it for your notes for today, plus a few of your problems for your extra classwork. Let me know if you have any questions, and remember that you have a quiz tomorrow.